Hello everyone. So in this video we will see a very important concept. On the basis of this concept in JEE Advanced 2026 they have asked the question. And this concept is regarding the orthogonal matrix and the vector. See, we all know that in the orthogonal matrix, see if A is orthogonal matrix, then we know that A into A transpose, number one, A into A transpose is equal to A transpose into A, that is equal to I. This concept we know that. Okay, A into A transpose or A transpose into A is always an identity matrix. That is the inverse of A is A transpose here in the orthogonal matrix. That is A inverse is A ka transpose. Also we know that the determinant of A is always either plus 1 or minus 1. This also we know regarding the orthogonal matrix, that the orthogonal matrix determinant is either plus 1 or minus 1. That concept is also there, plus 1 or minus 1. Okay, this is the very common concept regarding the orthogonal matrix. Okay, fine. Now, one more important aspect with respect to the vector which is corresponding to this orthogonal matrix, that you have to also know. What is that? See, we know that example A is sine theta minus cos theta and sine theta. Now this is what? This is an orthogonal matrix. Correct? Determinant is coming to be 1. So therefore this is an orthogonal matrix. So determinant is plus 1. Orthogonal matrix A into A transpose we will do. We will definitely have the identity matrix. Okay, that is the A inverse is equal to its A transpose. That's fine. Now the question is, what does that vector concept is here? What is the importance of that vector concept you are talking about, sir? Because in this advanced 2026, this matrix and vector concept both are involved there. Now see, if I found the vector, see, vector by the row. So this vector is, suppose karo u is sine theta I minus cos theta j. Correct? What can you say about this vector? Definitely this is a unit vector, correct? This is a unit vector. The modulus of the magnitude of this vector is modulus of u is square root of sine square theta plus cos square theta, and that is coming to be 1. Similarly, if I found a vector with the elements of the row 2, that is again coming to be a unit vector. Hold on. If we find out the vector along the column 1, that is again coming to be a unit vector. And similarly so I can say that if we find the vector with the elements of the any row or any column, that is always coming to be a unit vector. But one more important aspect is there. See, suppose I take V equal to, here I am writing V equal to the first row, now I am taking second row, that is cos theta I plus ka sine theta ka j. I am talking about the 2 cross 2 matrix. The same thing is also valid for any square matrix. Okay, because we are talking about the orthogonal matrix, that means the matrix has to be square matrix. That concept is already, we know that, correct? So now here u is sine theta I minus cos theta j. V vector is cos theta I plus sine theta j. We have formed the u vector with the elements of row 1 of this orthogonal matrix. We have constructed the second vector v with the elements of row 2 of this orthogonal matrix. And what we are observing here, that u dot v. U dot v will be sin theta into cos theta, then plus sin theta into minus of cos theta, that is sin theta cos theta minus sin theta cos theta, that is u dot v is coming to be 0. So this is the important aspect, that both vector and orthogonal are the concept, vector concept we can apply over here in the orthogonal matrix, that the vectors formed by elements of any row is always a unit vector, or elements of any column is always a unit vector, and those unit vectors dot product is always coming to be 0. That is also again an important aspect. So this concept we will apply over here to solve the JEE Advanced 2026 problem. What this problem says, they have asked these questions in matrix matching question. Okay, now here look at here, m is given by alpha 1 by root 2 minus 1 by root 2 1 by root 3 beta 1 by root 3 gamma delta mu, and this condition is important. What is that? M into M transpose is I. This M into M transpose is I shows that M is orthogonal matrix. Orthogonal matrix. Correct? This M is orthogonal matrix. So this M into M transpose is I, that shows that M is orthogonal matrix. Now coming to the vector concept. Now U is alpha I plus 1 by root 3j plus gamma k. Now see that U vector is formed by using the element of this column, column 1. V vector 1 by root 2 I plus beta j plus delta k. So V vector is formed by using the elements of second column. So this U vector is a unit vector. This V vector is a unit vector. Now coming to the W, minus 1 by root 2 I plus 1 by W is also formed by elements of third column. Correct? So these are the vectors formed by the elements of the columns. We can also have the vectors which can be formed by the elements of the row, that we can also form. So we can find out this alpha by using the row concept. So alpha square, here I am writing to find out the alpha square. So this alpha square plus 1 by 2 plus 1 by 2 must be 1 by using the concept that these are unit vectors. Alpha square I can find out as a 0, that is alpha is 0. Alpha is 0. Correct? 1 is find out. Now similarly I can find out beta similarly. Beta 1 by 3 plus beta square plus 1 by 3 is equal to 1. This is 2 by 3. 1 minus 2 by 3, that is 1 by 3. Therefore beta is 1 by root 3. Beta is 1 by root 3. Correct? Or plus minus, you can say that beta is plus minus 1 by root 3. Okay, no problem. Now coming to alpha we have find out, beta we have find out. We can find out now this gamma, you can find out delta, as well as you can find out mu. So alpha square is 0 plus 1 by root 3 square is 3, 1 by 3 plus ka gamma ka square must be 1. So gamma is 1 minus 1 by 3, matlab 2 by 3. Correct? Gamma square is, I am writing 2 by 3 only. Okay, gamma square we have find out. Okay, similarly I can find out delta. So 1 by 2 plus beta square plus delta square equal to 1. Beta square is 1 by 3. This is what? 1 by 3. So this is 3 to the 6, 3, 5 by 6. So delta square is 1 minus 5 by 6. That is 1 by 6. So one question is this delta square plus gamma square. So first question is, what is the value of gamma square plus delta square? What is the value of gamma square plus delta square? 2 by 3. This is gamma square plus delta square 2 by 3 plus 1 by 6. that is 6, 5 by 6. This answer is 5 by 6. Correct? This gamma square plus delta square is 5 by 6. Got it? Okay, this is gamma square and delta square. So we have find out gamma square, we have find out delta square. Now just we have to find out this mu square. Correct? So gamma square plus delta square plus mu square equal to 1. From this we can find out gamma square plus delta square is already we have find out is a 5 by 6. So mu square is 1 minus 5 by 6, that is 1 by 6. So mu square is again u by 1 by 6. This mu square is 1 by 6. Okay, fine. So gamma square find out, delta square find out, mu square find out, alpha find out, beta find out, alpha square find out, beta square find out. Now the question is, they are asking gamma square plus delta square 5 by 6 is okay. Now u dot v cross w. I said that the dot product of this vector and this vector is 0, or this vector and this vector is 0, okay, or this vector and this vector is 0. So that is u dot v is 0, v dot w is 0, okay, u dot w is also 0, that we know that. Now they are asking u dot v cross w, dot product. Okay, how we can find out this u dot v cross w? What is the value of u dot v cross w का magnitude? Triple scalar triple product है ना? This is what? Scalar triple product. So this is coming to be what? This is coming to be what? How can you find out this u dot? Okay, just find out first u cross v cross w. This is u cross v cross w. This formula is u dot w, which is 0, into v minus u dot v, which is again 0, that is w. So 0 minus 0, that is 0. So this answer u cross v cross w is coming to be 0. Correct? This answer is 0. Correct? This answer is immediately you can find out as a 0. Now what about this u dot v cross w? How can you find out? This is a scalar triple product. I can use the determinant, that is alpha. Alpha is 0, 0, 1 by root 3. Gamma is what? Gamma is plus root 2 by 3 or minus 2 by root 3, whatever it is, like that. V, or you can use some property, na? You can use u dot v cross w. Let us find out. Now I can delete this. Correct? So we have to find out u dot v cross w. U dot v cross w. This is something like that, scalar triple product you can take. Now v cross w, v cross w, v cross w, we can find out. Correct, by cross product. And then u. So u is what? What is that u? Oh, I have deleted u. I have deleted u. Okay, no problem. This can be done. What is u? Okay, this u dot v cross w, where these are unit vector, na? So this is simply unit vector. So this is simply u v w ka scalar triple product. That is something like that, scalar triple product of I, j and k. And this is always coming to be 1. So no need to determine that determinant value. Find out that determinant value, it is coming to be 1. We know the property that the scalar triple product of unit vector I, j and k is always 1. Here u, v, w are unit vectors. So straightforward you can say that this answer is coming to be 1. Now here x u plus y v plus z w equal to z, then we have to find out the x. Question number 4. Now this is again interesting. See, you want x, so therefore you have to take the dot product with u. When you take the dot product with u, you will get the answer. See, this is u dot x u dot plus y v plus z w, and that is equal to u dot j. Correct. So this will give x, because u dot v, u is modulus of u square, which is 1, that is 1. And u dot v, y is scalar quantity, u dot v is 0, u dot w is 0. Now you have to find out u dot j. So that u vector we required. So I think that this is u vector is something like that, no? Alpha I जो 0 था, that is 1 by root 3 j, and then gamma k, something like that it was there. Correct? Alpha is 0. Now when we dot product with j, so this factor will come there, 1 by root 3. So therefore x is directly, you can find out as a 1 by root 3. This is 1 by root 3. Correct? Correct.